So here we've got a hotspot volcano question. So I've got the two questions at the top there. Explain how the island chain of Hawaii formed. So you might in an exam be given a picture like you were in one of the mocks, or it might just say explain the formation of a hotspot volcano. Maybe in some of the questions it says use a diagram, others it doesn't. Again, my advice is always, as you would know, use the diagram that you've got here. It's a bit more of a kind of complex diagram because it's better if you do it in 3D. But essentially the way that for someone who's not great at art like me, the way that I always tend to think about drawing it is simply, if I draw one at the top here, I've got kind of almost like a V shape that doesn't join two curved lines, and then all I'm doing is drawing kind of a square that's going off into the distance. So if you can see, that's kind of like a mini version of that, and then all I've got is this plume that comes up with the volcano, and then I tend to do my islands going off with my arrow pointing sort of the plate movement there. And in a sense, once I've labelled that up, it does exactly the same as the bigger diagram here. Okay, so how does it form? Well, let's go through actually before we even answer the question, because it's a bit of a weird one. As it says on the top tip down the bottom there, it's the only volcano type, which really we're going to look at, which is formed away from the plate boundaries. There's still actually a little bit of a question about how they're formed. There's still some debate. Essentially, for what we're looking at is a combination of two factors. This plume of magma comes from very low down in the mantle. That's different to convection currents. Normal convection currents, which happen at plate boundaries, which we've talked about a lot, is just the heat coming away from sort of the core. It's pushing magma up towards the surface, and it's kind of creating kind of a specific movement in the mantle. This plume is a much more specific, localized, and what I mean by localized is you can see it's kind of sort of a very thin, particular sort of trajectory, sort of up towards the surface. So it's moving up this way up to the surface. So it's not a kind of a general movement of the magma. It's one specific kind of almost like tube of, or as it says there, plume of magma coming up towards the surface that is going to try and break through the plate. Now, if that's combined with a weakness at this point, and a different colour, so it kind of makes it a bit clearer. At this point here, as it says, the lithosphere or the plate, then what you've got is that you've got this powerful, almost like a pump of magma pushing up from below. And if you've got a particular thin part of the plate or a weakness in the plate, it's going to try and break through. Okay, so how do we describe that within 4 marks we've got? So this is what we're looking for. So a large plume, and it's always just easier to describe it as that because that's the right word, of magma pushes up from the mantle and begins to melt through the bottom of the plate because it's very hot. It's being pushed up by pressure and force. So that's going to be your first point. This plume pushes up through cracks and faults in the plate, and if the magma reaches the surface, it creates a hotspot volcano, which is exactly what's happened in Hawaii. So it's this plume pushing up, pushing through to the surface. Now, the other thing to note here is that one of the questions that people always get asked, or students always get asked, is kind of which way is the plate movement. You can kind of get yourself all messed up about, well, why is it moving? How is it moving? The plume never moves. So the plume is in one stable position. But as we know, plates do move, okay? So they move over the top of the plume. And what that means is that whilst the plume stays in one place, the plate has moved into a different position. So as the plate moves along, new islands are being built. if a question ever asks you about which way the plate movement is, it's always going from, as it says on here, new to old. So the plate movement is always towards the old. Okay, in this one here, this is where Hawaii is currently. Okay, and this is where the older islands are. So on this one, it's going towards there. So if we just click on to the next slide for a moment, you can see that I've put it on the top, so you can kind of see how that works. So the plume doesn't move, however the plate it is on below it does. This means over time a chain of islands, so these islands here kind of are classified as a chain, they're all kind of part of the same thing, with the oldest island being furthest away. So if ever you've got to label it, the oldest island is always the one that's further away from the active volcano, sort of here, and the direction of the plate movement is always from young to old. Okay.